I'm in this book, Comets, Visitors from Deep Space, by David J. Etcher. And I'm on page 134, The Expanding Science of Comets. For some years, beginning in the 1990s, it became trendy for scientists and laypeople to jump on the bandwagon of the idea that comets supplied huge amounts of water to early Earth. Conferences included considerable talk about the notion. Various writers pounded out books suggesting the idea was ironclad. Several studies cropped up adding apparent weight to the evidence that much or most of Earth's water rained down from outside the atmosphere when Earth was in its formative years. At present, however, it seems to be one of those cases where lots of people draw sweeping conclusions based on a few studies, a few meetings, a few books. That's a disease that permeates culture these days, believing that one study warrants a concrete, permanent conclusion. But that's not the way science works. Instead, it is a slowly developing, enormous machine with numerous researchers and studies grinding away at the best conclusions. They develop over ample time frames as data are gradually refined. The last decade has pushed the idea that lots of Earth water originated from comets into a relatively weak position. I notice things like this where it says this is how science works, this is not how science works. But he falls into the trap yet again. He talks about a disease where certain facts are unquestionable based off a few publications or a few ideas. And the unquestioned assumption here is that Earth was always basically the same size that it is right now, with the amount of water content being the same as it was in the past. Yet they never question it. It was assumed through uniformitarianism, which was invented in I think the late 1700s, early 1800s, that Earth was always the way it is now, and it formed as is. Maybe there was a bit more lava back then, or volcanoes and whatnot. And maybe the atmospheric composition was a little different. But as to the mass of the Earth was about the same mass. It formed from rocks clumping together without mechanism. And it just has been like this for billions and billions of years. Yet, it's disappointing to see that they have taken that assumption with the full realization that the objects in our solar system are vastly different. It's disappointing to see that astronomers and geologists work hand in hand and they don't talk to each other. A geologist who looks at the Earth just looks at the Earth, and an astronomer looks at the stars. They just look at the stars. They don't put two and two together. They don't look at Neptune and Uranus or Jupiter and Saturn and think, wow, maybe that's what Earth looked like in its past. And they don't take the conclusion that stellar metamorphosis does either, because that field is crowded out with nuclear people who claim that young planets are nuclear reactors. So now we have, different kinds of objects out there when they're all the same. And that's based off of a few case studies. So it's like, that's the way science works. That's not the way science works. Well, yeah, that actually is the way science works. At least big science. It works. What they want to claim it to be is something other than what it actually is. They say science is a slow churning and it's slow progression. No, it's not. It's more like a step thing where they make a few studies and they take a step up, and then they base everything that they believe on those few studies, and then it levels out, it plateaus for hundreds of years. And then it steps up again, and then it goes again. So there's a time for revolution, and then there's, revolution would be up, and then there's a time for, what I can't remember what that word's called, but it just plateaus. It stays the same. There's no progression at all, really. And that's happening with particle physics too. Is that for the past 40 years they've hadn't made any major discoveries in particle physics that really have changed our understanding of nature. And that was what's called the nightmare scenario in particle physics, but I don't want to talk about that. Back to the Comet book here. And it says here, to investigate the possibilities, planetary scientists want to know as much as they can about the conditions on the early Earth. We know that the Earth was cooler in its early history, and that the young sun produced about 40% less radiation than it does today. With such a faint early sun and a cool early Earth, what were conditions like on our planet? He says that science doesn't work off a few publications, He he states something and completely goes right back to what he just refuted in the previous paragraph. They want to know the conditions on early Earth, and then they assume Earth has always been orbiting the sun. So that's completely false too. And it's like they also assume that the sun and the Earth are around the same age. And it's really, really weird that they do that with people who understand the theory I'm developing. It's like, how is something like the sun, where it's huge, it's bright, it's massive, its diameter is like 110 times the diameter of the Earth, how is something like that in the galaxy the same age as the Earth? It has the fucking things like the Grand Canyon, which took millions and millions of years to form, and rocks and minerals and solid ground. How is something that looks like the Earth and has radiometrically been measured to be billions of years old the same age as something that looks very young and radiant and energetic? And that's obviously based off of one study where they said that, well, this is how the sun is powered through thermonuclear reactions, and everybody accepted that. They never questioned it. And then they formed entire fields of research based off of a single conclusion. But anyways, yeah, it's strange, because if they would just look around them, if they would look in outer space and realize that stars contain a shitload of hydrogen and stars contain a shitload of oxygen, to form water worlds, or to form water in general, all that would need to happen is that ionized hydrogen and oxygen would just need to combine together to make water. And the water would rain down in the interior of the star long into its evolution, forming a giant singular ocean that completely encapsulates the core of the object, which obviously is after many other stages of chemical composition and various other processes. And we see where they make these huge mistakes. It's very cool taking this theory and just applying it to books like this. Continuing on. Zirconium silicate, or ZrSiO4, is an extremely stable mineral over long intervals of time that also contains tiny amounts of radioactive impurities like uranium that enable dating the crystallization ages of individual grains. So they can find out the crystallization point for zirconium crystals, and then other types of material that's in there as well. It's really advanced stuff. I like researching that kind of thing, but they also have to realize that if the Earth wasn't like this, if it was ionized material, then there were no crystals being formed in the Earth's early evolution. The very beginnings of Earth's life, there's no evidence of how the Earth was in its early history, because the crystals couldn't have formed. The molecules there would have been broken apart as soon as they were made, because the Earth was way too hot. And the only way to come to the conclusion that the Earth was really hot is to make observations of how many young Earths are out there, and there's hundreds of billions of them. The fact that scientists call them stars really does us an injustice. We could have a great understanding right in front of us, but it's ignored because they assume the Earth was always about the same size and always had about the same types of chemicals throughout its formation, and it's just not good to assume that. But they don't ever talk about it in this book, believe it or not. They don't throw their assumptions out there. But anyways, I think I want to go ahead and talk about that for a second, because it's not that the comets didn't bring water to Earth. It's more or less they need to understand that Earth isn't as is, that it's the end result of many billions of years of evolution. We're looking at the end result of something, of a process that is well beyond what could have been imagined in the past with, earlier scientists and philosophers. But now that we have the exoplanet data coming in, we can take a gander at all the pre-Earth Earths in many different stages of evolution and play a giant game of connect the dots. And that's going to help considerably in understanding how the Earth came to be the way it is today. Alright, you guys. Later.